Hey everybody, we are in All Things Algebra, Geometry, 4-2, Angles of Triangles. I just finished problems 1 through 7, so I am ready to move on to the second part of this lesson. So I'm just going to turn the page and continue on. All right, so I'm looking at problem number 8. All right, well, in the last video, I was telling everybody to split up the triangles for kind of where you can begin. And I noticed that on problem number 8, I want to start right there because I can find angle 1 given that I have 2 of the angles of this triangle already. So in order to do that, I need to know that 3 angles of a triangle add up to be 180. So here goes. I'm going to take 180. I'm going to subtract 41 and also the 75. That's going to get me angle 1. All right, so 180 minus 41 minus 75. 64. All right, angle 1, 64. I want to move over to this other triangle, and you could have actually started here. The reason I know that is because I have 2 angles inside this orange triangle also. I have the 90 and I have the 54. So this is going to get me angle 3. So I'm going to take 180. I'm going to subtract 54 and also the 90. And that's going to get me angle 3. So 180 minus 54 minus 90. 36. So angle 3, 36 degrees. Now, if you're sitting here going, well, angle 2, is that an exterior angle? It is not. It is not an exterior angle of the triangle because it does not extend out from one of the sides. So let me show you what I mean by that. This is what an exterior angle looks like. It has to be a continuation of one of the sides of the triangle. So this rule right here does not apply to angle 2 in this problem because it does not extend from a side of the triangle. So this is not an exterior angle. However, what I do see is that I have a straight line, and those angles add up to be 180. Talking about the 64 degree, angle 2, whatever it is, and this 90 will add up to be 180. Or, here's a shortcut. If the angle on the right is 90, the angle on the left is 90. Because, hey, what's 90 plus 90? That's 180. So the shortcut, if you want a shortcut, is just to take 90, subtract 64, and that will be angle 2. So if you're a person who's always looking for a shortcut to make your life easier, that would be it. 90 minus 64. Okay, looks like angle 2 is 26 degrees. 26. All right, there's number 8. So hopefully as I go, I'm showing you guys some ways of thinking. But if you get stuck on something, pause the video, ask me, send me a message on YouTube. I will respond. Ask your teacher. All right. Okay, number 9. All right, I said that word skinny 11. What that means is that I have lines that are parallel to one another. Now, how does that help me? What that does is tells me that alternate interior angles are equal, alternate exterior angles are equal, corresponding angles are equal. Consecutive angles are supplementary. Okay, let's see. Well, there's my triangle. Unfortunately, I only have one angle inside this triangle. I only have that 73. So can't really say, hey, let's take the 2 angles from the triangle, subtract from 180, and boom, I've got the third one. What I do see is I can find angle 3 by realizing these are the linear pair. They're supplementary. So I'm going to take 180. I'm going to subtract 73, and that will get me angle 3. 180 minus 73. So it looks like angle 3 is 107. Okay. Well, how can I use that? How can I use the 73? How can I use the 107? How can I use the 49? Okay, well, there's several things that come to mind. May not be necessarily the thing that you think, but this is what I'm looking at. Let's see if I can color this up. This 107, I'll piggyback off what I just did. That 107 angle. And the combo of the 49 and angle 2, those are alternate interior angles. What that means is they're equal to each other. So what I'm saying is this. There's a number that will add to 49 that will be 107 because alternate interior angles are equal to each other. There's your transversal. If you need to see it, I'll mark it out longer. They're equal to each other. So something plus 49 equals 107. I guess the question is, what is it? So what is 107 minus 49? Whatever it is, that's going to be angle 2. So 107 minus 49. 107 minus 49. Looks like it's going to be 58 degrees. So angle 2 is 58. Well, now I have two angles inside that triangle. I have angle 2 is 58, and I had the 73 that they gave me. So yeah, I can now find angle 4. Now if you're talking about, hey, find an angle 1, go ahead. I'll get to angle 1 and I'll get to angle 5 in here in just a minute. There's multiple ways you can find those actually right now. You don't need angle 4 to angle 5. Yeah, you can use the 49 to find angle 5. But yeah, I'm looking at the triangle. 3 angles inside a triangle add up to be 180. So I'm going to do 180 minus 73 minus 58. And that's going to be angle 4. 180 minus 73 minus 58. Looks like angle 4 is 49 degrees. Angle 4. Whoop, 49. Okay. So there's multiple ways to find angle 1. There's also now multiple ways to find angle 5. Okay, one thing you can do to find angle 1 is to realize that these angles up here add up to be 180. I'm talking about the 49, the 58, and this angle 1, which hopefully you realize is 73. Because alternate interior angles are equal with these pink ones I did. Alternate interior angles on the other side will also be equal. What I'm saying is that angle 1 is 73. That's probably the easiest way. So if you're looking for a shortcut, alternate interior angles are equal to each other. Therefore, angle 1 is automatically 73. No math involved. Angle 5 over here, consecutive to the 49. Just like 107 and the 73 are consecutive. They add up to be 180 because we proved it right here. You can do 180 minus 49. Or you can just say, hey, look, there's my linear pair. 180 minus 49. Either way, you're going to get angle 5. Or you can realize, hey, angle 5 is an exterior angle because it keeps going from the side of the triangle. I got to just add 58 and 73. And you'll still get the same darn answer. So there's multiple ways to solve this problem. And that's the nice thing about geometry is you don't have to do it my way. You may see it as consecutive to 49. You may see it as the linear pair to 49. And you may say, well, hey, didn't we just learn about that exterior angle thing? And you may add 58 and 73. Either way, you get the same answer. All right, 180 minus 49. Looks like it's going to be 131. So angle 5, 131. Number 10. Woo, Lord have mercy. Look at that. All right. Okay. Well, this is what I noticed right off the bat. I got this huge right triangle over here. That box means 90. I have a 53-degree angle. I could find angle 3. So that's what I'm going to start off with doing. If you want to start with something else, do you. If you want to start with angle 6, you can. Yeah, You can start off with angle 4 if you want to. You can do that. Yeah, I kind of go straight for triangles just because that's kind of what I've been trying to do. So I'm going to take 180. I'm going to subtract 90 and 52. My bad, 52. That's going to get me angle 3. And then I'll kind of go from there. So angle 3, going for angle 3. 180 minus 52 and 90. This is going to get me angle 3. All right, looks like angle 3 is 38. Okay, how can that help me? Well, I notice now that I have a right angle with 2 and 3. That means angle 2 and angle 3 add up to be 90. So what number plus 38 makes 90? Let's do that. 90 minus 38. What number plus 38 makes that box right there? So 90 minus 38 is going to get me angle 2. 90 minus 38 is 52. Interesting. I'm looking at the same numbers here. So 52 degrees is angle 2. Right there. 52. So looking at this angle down here, what do you think angle 6 is? If you realize this is 52, which is alternate to this 52, alternate interior, what do you think angle 6 is going to be? Well, if you think it's 38, you're right. So angle 6 is 38. I don't know why I just did that. There we go. 38. Okay. Well, I don't know what you're looking at, but I'm looking at this triangle right there. I now have 2 angles. I have the 86 and I have the 38. So I'm going to find angle 5. If you're doing something else, then that's great. Okay, that's not a problem. You may go find angle 4 first by realizing, hey, that's the linear pair right there because they make a straight line, and that's great. Do you. Do you. You're going to hear me say that a lot, especially if you're in my class, because geometry is not my way or the highway. There's multiple ways of working these problems and getting the answer. So I'm going to take 180, I'm going to subtract 86 and 38, that's going to give me angle 5. So I'm looking for angle 5 right here. 180 minus 86 minus 38. It looks like it's going to be 56. So angle 5, 56. Well, there I have another box right there. And that means it's 90. So angle 1, whatever it is, plus 56 is 90. So I'm going to do angle 1 next. So 90 minus 56 will get me angle 1. 90 minus 56. It's like angle 1 is 34. So if you did it a different way, you probably already have angle 4. But now I'm looking at this triangle where I have 2 of the angles. I have angle 2 is 52, and I have angle 1 is 34. So I'm going to find angle 4. I can add those, subtract from 180, or I can just say, hey, 180 minus 86 is angle 4. Whichever one you want to do. Same answer. 94. Angle 4 is 94. All right, you guys. There's number 10. And again, you do not have to work it my way in that order to come out with correct answers. Now, geometry is figures. You just can't say, hey, you must do this first. You must do this second. So if you're a steps person, you're going to find geometry doesn't really work that way. There's very few things in geometry that, hey, is step number 1. This is what you do. Hey, here's step number 2. Here's what you do. Geometry is not like that. Okay, number 11. Oh, well, you probably know what I'm looking for. I'm looking for a triangle where I have 2 of the angles already. And, I just don't see one. This triangle, 4, 3, and only have one angle. This triangle, 47, don't have it, don't have it. This triangle, 42, don't have it, don't have it. And this triangle, 71, don't have it, don't have it. Well, what would you do at this point? What would you do? What do I have here? I have parallel lines, which means my alternate angles are equal. You know what I'm going to do? I'm not even going to worry about that. I'm looking at that 71-degree angle. That 71 is going to allow me to find angle 2 and then 3 and 5. Because what I see are vertical angles. Angle 71 is opening in an opposite direction made from the same two lines as angle 2. So what's angle 2? If you said 71, I love you. Angle 2 is 71 degrees because it's vertical to the 71 degrees. Now, this triangle up here, I have 2 of the angles. So I can find angle 1 pretty easily just by doing the 180 thing of a triangle. So if you want to go ahead and do that, you can. Next thing I'm going to do, though, is I'm going to realize that 3 and 5 are vertical. They are equal to each other. They're opening them in opposite directions made from the same two lines, that big gigantic X there. So whatever 3 is, 5 is. Whatever 5 is, 3 is. And since they make a linear pair with a 71, I'm going to do 71 subtracting from 180. 180 minus 71 will get me angle 3 and angle 5. 180 minus 71. So angle 3 is 109. So is angle 5, 109. All right. So look what I have. This triangle over here, I now have 2 of the angles. So I can do the 180 thing for a triangle. To the left, I have 2 of the angles. I have the 109 and the 36. So I can do the 180 thing for a triangle to get angle 4. And yeah, down at the bottom. Ooh, okay, let's come back to that one. That is a triangle. And if you're wondering, well, why does she sound like that? I don't have angle 8 or angle 7 yet, so I'm going to have to worry about those parallel lines after all. All right, let's find angle 1. 180 minus 47 minus 71. I'm looking at this thing that I highlighted yellow, this yellow triangle. 180 minus 47 minus 71. 180 minus, what did I say? 47 minus 71. All right, there it is, 62. Angle 1 is 62. Okay. What am I need over here? I need angle 6. So this pink triangle, I'm going to take 180. I'm going to subtract 42 and 109. This will get me angle 6. So 180 minus 42 minus 109. Okay, it's going to be 29 degrees. Angle 6. 29 degrees. Okay, over here to the green one. I have 2 angles, 109 and 36. I'm going to subtract those from 180 to get angle 4. So 180 minus 109 minus 36. $35 degrees. Angle 4. 35 degrees. Okay, to this blue. All right, what do you guys think? I'll only have one angle inside that blue triangle down here. This is not a linear pair. This is not a linear pair. The problem doesn't tell me anything's been bisected, so I have to rely on this weird symbol right there, the parallel lines. Those alternate angles are equal to each other. All right. So if you're sitting there going, yo, what you mean by that, woman? I'm looking at this angle on the top left and its alternate angle on the bottom right. Those are equal to each other. So 47, angle 7 is 47. Alternate angles are equal. And if you're looking at this going, but hang on, this blue triangle is bigger than this yellow triangle. I'm sure that's absolutely correct. It is bigger. We're going to learn about dilations later. Anytime a triangle has been dilated, maybe to a bigger one, or if a bigger triangle has been dilated to a smaller one, the angle size, they don't change. Only the side lengths are going to change. The angles don't change. So if you're sitting here going, well, is angle 8 62? Absolutely. Oh, hang on, y'all. And I'm back. Okay. Woo! 12, 13, 14, and 15. Okay. This is going to be kind of a nasty problem, but those three angles add up to be 180 degrees. I'm going to find x. I'm then going to plug in that value for x to find angle D, angle E, angle F. Now listen, if there was a shortcut, I promise you I would show it to you. But nothing has been marked equal here. Angle D, E, and F are all different sizes because they have not been marked equal. So unfortunately, for me and for you, there is no shortcut. 9x plus 3, which is angle E, is going to add to 11x minus 21, which is angle F, which is going to add to the 5x minus 2, which is angle D, and that's going to equal 180 degrees. Three angles of a triangle equal 180. Now, I am going to combine like terms. I'm talking about the things that have x's and also the things that don't have an x. Okay, so here goes. Just the x's. 9x plus 11x, that's 20x, plus 5x is 25x. 3 minus 21 minus 2. All right, well, 3 minus 21, that's going to be a negative 18. Negative 18 minus 2 is a negative 20. Okay. Let's see. Now that I got my like terms combined, this doesn't become too much of a bad problem. The opposite of subtracting, 20, the inverse operation is the correct term, is to add 20 to the other side. So 180 plus 20 is 200. Divided by the 25. Well, how many quarters go into $2? That should be 8. 200 divided by 25 is 8. Okay, well, now that I've got my x value, that 8, I'm going to plug it into the 9x plus 3 to get angle E. I'm going to plug it into the 11x minus 21 to get angle F. And I'm going to plug into the 5x minus 2 to get angle D. Now, the only thing I tell you is to pay attention to which one you're plugging into. That way, over here, you put it into the correct space. Because I will have my students that will get the 8 and then plug it in here and then put it for angle D. Now, they'll put it in for F, but they'll put it for angle D. So do pay attention. Do pay attention. All right, they want D first. I'll do D first. So 5 times 8 is 40. 40 minus 2. If you just said that, Miss Eccles, really, really fast. Do that again. So that, what'd you say? 5 times 8 is 40. 40 minus 2 is 38 degrees. All right, angle E. 9 times 8 is 72. 72 plus 3, 75. Okay, do that one more time, woman. 9 times 8 is 72 plus 3 is 75. Okay. Angle F. 11 times 8 is 88. Minus 21. So that's going to be, what, 67? Okay. Anybody have any questions or anything, let me know. I'm just going to keep on keeping on. Number 13. Same darn thing. No shortcuts. Nothing here has been marked equal to each other. I have Q, P, and R. They're all 3 different sizes, but it is a triangle, so they add up to be 180. 4x minus 22 for the Q angle. X plus 11 for the R angle. 10x minus 4 for the P angle. Equals 180. Like terms. If you're sitting there going, what are those? 4x plus 1x is 5x. 5x plus 10x is 15x. All right. The negative 22, the 11, and the negative 4. Those are like terms. So negative 22 plus 11 is a negative 11. Minus 4 is a negative 15. All right, so after our like terms, we got 15x minus 15 is 180. Add 15 to the 180. What's that, 195? And then divide by 15. Well, I have no idea what that is. 25 divided by 15. 13. Okay. So every x is 13. All right, that is to say, I'm going to take my 13 and plug it in to the 10 times 13 minus 4 to get angle P. I'm going to plug it into the 4 times 13 minus 22 to get angle Q. And I'm going to put in 13 plus 11 to get angle R. Okay. So angle P, 10 times 13 minus 4. Well, 10 times 13, that's 130. 130 minus 4 is 126. I don't know what 4 times 13 is. All right, 4 times 13 minus 22. Your computer or calculator will do order of operations. So I want to just let the calculator do the business. Looks like I get 30. And then 13 plus 11, 24. 24 degrees. Now listen, if you want to check your answer, if you'll just add those 3 together to verify that it equals 180, you know you pretty much have done it right. Unless you made some kind of silly mistake, you're good to go. All right, number 14, I have an exterior angle here. It is made up from the side of the triangle. So there is a shortcut. These 2 angles, we call those remote interiors. They will add up to be the exterior angle. So 13x minus 11 for angle A, plus 4x plus 1 for angle B, equals 18x minus 15 for the exterior angle. Okay, still got some like terms here. 13x plus 4x, that's 17x. Negative 11 plus 1 is a negative 10. 18x minus 15. I'm just going to bring that down because I haven't done anything with that yet. I am now, though. Listen, I am a creature of habit, and I like shortcuts. What I'm saying is this. It doesn't really matter what you move first. You can move the 17x. You can move the negative 10. You can move the 18x. You can move the negative 15 first. It really does not matter. But since I prefer a shortcut, I will always move the smaller x first. I'm going to subtract 17x. 18x minus 17x is 1x. Add the 15. And every x, 15 minus 10, is going to be a 5. All right. Now I want you to notice that there are 3 letters for each one of these angles over here. The reason they do that is because there are multiple angle C's. You've got the exterior angle C, you've got the triangle angle C. So you have to pay attention as to which one's which. Angle A is angle A. There's only one angle A in this problem. And angle B, remember the vertex is in the middle, there's only one angle B. But there are 2 angle C's. One of them is the inside, one is the outside, and you have to pay attention as to which one's which. All right, so you want angle A. That is, I'm going to multiply 13 times 5 minus 11. 13 times 5 minus 11. I don't know what 13 times 5 is. All right, looks like angle A is 54. Okay, next up is angle B. So 4 times 5 plus 1. Well, 4 times 5 is 20, plus 1 is 21. Okay, angle ACB. Tell you what, visual people. ACB is the angle inside the triangle. Now, what I would do is to realize what I just said. I just said that's a triangle. 3 angles inside a triangle add up to be 180 degrees. So to find this angle C, I would just do 180 minus the 2 angles that I have, 54 and 21. This will get me the inside angle to the triangle, angle C. 180 minus 54 minus 21. 105. 105. Now at this point, you got 2 options. You can do the plugging and chugging. 18 times 5 minus 15. This will get you angle C that's on the outside. Or you can realize there's my linear pair. 180 minus 105. Or you can say, well, listen, if this is 54 and this is 21, what's 54 plus 21? Boom, there's your answer. There's multiple options here, okay? Multiple ways to, figure this last one out. You can plug and chug the 5. The linear pair will be 180 minus 105. That'll get you the answer. Or this right here. This is the exterior angle. What's 54 plus 21? If you said 75, you're in business. Okay. Last but not least, and this is a long video, but these problems are not short. Exterior angle. One of the inside angles. 7x minus 32 is the other one. Equals 9x minus 8. Now, this is the point where I would start backing off and letting my students try this out on their own and walk around, or say, hey, try this. I'm going to work it super slow. Check your answers with me as you go, that kind of thing, just to gain their confidence, let them get their confidence level up. All right. Like terms. I don't care what you move. I move the small x first. And I tell my students that. Okay, I'm going to add to the other side the number that doesn't have an x to combine my like terms here. It does come out nice. I was a little bit worried. Yeah, it comes out nice. All right, there's all of my x's. Okay, so I'm going to plug into angle K. The vertex is in the middle. This will get me angle K. Angle J, that letter vertex would be this angle because the letter's in the middle. I got 2 angle L's, so you have to pay attention to which one's which. All right. So angle K, 7 times 17 minus 32. Okay, there's angle K. Okay, angle J. 5 times 17 minus 27. A couple of options here. There's my triangle. So if I want KLJ, that angle right there, I can just do 180 minus 87 minus 58, because those are the two angles inside that triangle that I have. And it'll get me 35. And then I'm just going to add these two together. Add those to make the exterior. It's a nice little shortcut, works every time, and I am really all about a shortcut. And there we go. All right, so sorry about this long video, but these problems were not short. If you have any questions, let me know. I'll message you back, I promise. And you can always ask your teacher. Good luck with those practice problems or homework or whatever your teacher assigns to you. And yeah, it's all you.